Okay guys, so this couple videos we're going to be looking at relationship between two categorical variables. Now remember, categoricals where we actually can put them into different categories. Okay, quantitative is when we can count. Categories are we label it like blue eyes, green eyes, hazel eyes, and that type of a thing. Okay, so we're going to be looking at finger lengths. Is there a relationship between gender and relative finger length? We take a sample of 452 U.S. high school students who completed a survey. The two-way table shows the gender of each student and which finger was longer on his or her left hand. We're comparing index and ring finger. Okay, those two right there. So the table comes up with that data there. That's 78, 45, 123 for the index finger. Ring finger 82, 152, 234. Same length was 52, 43, and 95 for a total. The total was 212 female, 240 males for a grand total of 452, which is what we wanted. All right. Is this an observational study or an experiment? That one's pretty easy, isn't it? This is an observational study because we're just observing. All right. Remember, observational versus experiment. Experiment, we have to change something. We're going to have a double blind or a blind, single blind test, that type of a thing. All right. Make a well-labeled bar graph that compares the distribution of finger length for females and males, and then we're going to describe what we see. I've started my chart, so you can kind of see it there. What I'm going to do is I'm going to go up and do a percentage for index for how many females there are in that type of thing, and then we'll come back and label those. Okay. Okay, guys. So this was a 37%. This was a 0.39. This was a 0.25. Over here we have 0.19, 0.63, and 0.18. This one gave me a total of 1.01, so a little bit of rounding error. This one came up luckily to exactly 1. So if that was asked, that's what would happen. All right. So here is my completed bar graph. The green represents the female, the red represents the male. I try to keep that color coded so we can see that. So then it asks us to write something up about this. So then I would just come in here, and again, we're going to say what we see. All right. So in the index finger, I see a larger proportion of females. Had a longer index finger. All the better to point at you. In the ring finger, the male or males had a longer ring finger, or should I say had a proportion bigger than the females. And then the proportion of females was bigger than the males for the same length. Then the males for the same length of fingers. Okay. All right. All right, so we'll stop there. Well, not before I stop, I want to just bring up a couple things. So the relationship between categorical, remember we can come into here and we can count it and still use our chi-test, our chi-test of significance. Because we can count, even though it's a categorical, we can still count them and put them into different things. We can do expected accounts. You know, we could do 212, 123. Let me do that real quick. So we expect that to be about 57.69. And then we could do the same thing and do that two matrices and still come up with that. Is there a significance difference? And guess what we're going to be doing here in a milliminute. This is the very same thing. Okay? All right, we're going to pause it there for real this time. So this is going to be a chi-square test for independence. Now the difference between independence and homogeneity, you know the word I can't say, is homogeneity comes from multiple treatments, multiple sources, okay? The independence is looking at one sample with a variety of categorical outcomes, okay? So we're going back to our index and ring finger, okay? All right, so the conditions are exactly the same. I'm just going to put a little remembrance up there for you that our 10% condition is met if we're doing this without replacement. So if we're just doing this without putting the cards back, then we don't have to do the 10% condition. If we're doing it with replacement, then we need to do our 10% condition, right? The alternative hypothesis and null hypotheses are kind of written in a specific format. So there's two different ways you can do it. The first way is there's no association between two categorical variables in the population of interest. So there's no association between the length of the fingers between male and female. And then there is an association between two categorical variables in the population of interest. Or our two categorical variables are independent in the population of interest. Two categorical variables are not independent in the population of interest. So what we're going to do is we're going to use our example of our finger length, okay? All right, so let's do that test. Let's do a chi-square test for independence, all right? So first thing we're going to look at is random, and that was stated in the narrative, okay? Our 10% condition, the data comes from a sampling without replacement. So it does not need to be checked. Okay. Large counts. So going back to my chart, I need to do my large counts on this one real quick. So I'm going to pause it and do that real quick for us, okay? Here are my my expected counts. They're all larger than 5, so we are good to go from there. So I'm going to come down here and say all are larger than 5, okay? So then I'm going to write out my narrative for my null hypothesis, okay? So I'm going to do the first one. So there is no association between gender and how'd they put it? Relative finger length. And the population of U.S. high school students who filled out the survey. Okay. Then my alternative is, I'm going to say there is an association between gender and relative finger length in the population of U.S. high school students who filled out the survey. All right, so let's go ahead and do this on our calculator. Okay, so the matrix are going to be 3 by 2, and then we'll get back together, okay? So I just want to show you my matrix. This is my expected accounts, and then my observed counts. So I'm going to go down to, I'm going to go to my test. I'm going to go to C. That all checks out. So then I'm going to come down here and say my chi-square test. My chi-square says that it's 29.0233. My p-value is 4.98 times 10 to the negative 7th. That's basically 0. Okay. And then my degrees of freedom is equal to 2. Alright, so let me pause it real quick so I can do. Alright, so our p-value is basically 0 like we said earlier. So there's our significance level at 0.05. So we reject our null hypothesis and we state we have convincing evidence that there is an association between gender and relative finger length in the population of U.S. high school students who filled out the survey. So there is some type of association. What we don't say is what it is or anything like that. We just say there is an association. All right. Okay. So one more video, and it should wrap the entire thing together.